Hello everyone, welcome to this video on symbol table management. A key component in compiler design. Whether you are a student or a developer, learning about how compiler works, understanding symbol table will help you grasp how programming languages enforce rules, optimize code and generate machine instructions. Let's dive in. What is symbol table? A symbol table is a special data structure used by a compiler to keep track of all the identifiers such as variable names, function names, class names, constants, etc. encountered during the compilation. For each identifier, the table stores important attributes like name, the identifier itself, type whether it's an integer, float, etc. Scope where in the program it is accessible, that is global or local. Memory location where it's stored or will be stored in the future. This table plays a central role throughout the compilation process. To understand its important, let's see where the symbol table is used across different compiler phases. In lexical analysis, the program is broken into tokens. The identifiers are recognized and passed to the symbol table. The syntax analysis builds the parse tree. The structure depends on the correct use of variable function tracked by the symbol table. Semantic analysis ensures that the identifiers are used correctly, like no type mismatch or undefined variables. And finally, in code generation, the symbol table helps the compiler translate high level code into correct and optimized machine code by referring to the memory locations and types. Let's see the purpose of symbol table. Symbol table links identifiers to its attribute, ensuring correct declaration, avoid duplicate or conflicting declarations. Scope management, making sure variables aren't used outside their valid range. Error detection helps find semantic errors like undeclared variables. Type checking ensures type rules are followed, no adding a string to an integer. Code support, during code generation, it provides addresses and data needed to generate the machine level instruction. Let's go deeper into each function. First is identifier association. Every identifier is mapped to its property. For example, int x adds an entry, name x, type int, and scope is global. Declaration prevention. Duplicate declarations like writing int x twice in the same scope are flagged. Scope resolution. If you declare int x globally, then float x inside a function, the symbol table helps resolve which one to use based on where you are in the code. Error detection. Say you try to use a variable before it's declared or pass a string where an int is expected. The compiler uses the symbol table to detect these types of issues. Code generation support. When converting to machine code, the compiler pulls the address and type information from the symbol table to generate accurate instructions. Operations on symbol table. To perform this task, the symbol table supports three operations. First is insert. It adds a new identifier entry to the symbol table. Lookup. It searches for an identifier to check if it exists and fetches its properties. Delete. It removes all the declared identifiers declared within a certain scope, like when a function ends. Modify. Update the properties of an identifier if it changes. Display. It prints the current state of table for debugging or visualization. Implementation techniques of symbol table. Now, how is a symbol table actually implemented? There are multiple data structures that can be used, each with pros and cons of their own. First is linear list, easy to implement, stores entries one after another, but for lookups it is slow O of n time, so it's used only in a small or simple compilers. Second is binary search tree, that is BST. It offers fast operations with log of n time, but unbalanced tree may degrade its performance. Hash table, it is most widely used method, provide an average case constant time operations for insert, delete and lookup. Collision handling strategies like chaining are used in this. And last one, especially efficient when identifiers share prefixes like autocomplete systems or languages with many structured names. Let's see an example of symbol table. So here is how typically a symbol table will look. Each row details an identifier. It includes its name, its type, the scope and memory address. This tells the compiler x is a global integer stored at 1000 memory address, y is a local float inside a function or a block, and function is a global function entry point. During compilation, this information will guide the type checking and machine code generation. To wrap up with, the symbol table is a central component of a compiler, almost like it's the memory or internal brain. It ensures semantic correctness by maintaining accurate information about all the identifiers in the symbol table. It enables efficient code generation, mapping up high level code to low level machine instruction. The symbol table make it very easy and efficient to convert high level code into low level machine instructions. And most importantly, the performance of symbol table directly affects how fast and efficient the compiler learns. So that was all about what is the symbol table, its working and operations we can perform on symbol table. Thank you for watching. If you found this video helpful, please like, comment and subscribe. Let us know in comment if you like to dive into a compiler internals like parsing, intermediate code generation or lexical analysis. Thank you for watching.